Some arguing right now. When we paint a room, 9 times out of 10, we paint what? Walls only. All right? Now, don't lawyer ball me. Well, what about the door? What about the windows? It's a panic room. I know I say it's his living room, but it's his panic living room. So he can continue to watch Netflix as the world crumbles around him. Okay? So no lawyer ball. Yeah. All right, so we're going to do the easy way, and we're going to do the better way. Everybody cool? All right. So the easy way says that I have one wall that is how big? What are the measurements of this one wall? 4.1 meters along the ground and 3 meters up the side. Yes? Agreed? And then I have a second wall that is 5.3 and 3 meters. Yes? Everyone agree? Now, if I just do length times width, I'm going to get square meters, aren't I? What do I need? Square feet. So I better change these, right? Feet to meters, or meters to feet, is 3 divided by 0.3048, right? If we wrote out the whole fraction, yeah? And 4.1 divided by 0.3048, and 5.3 divided by 0.3048. So you're going to get something like, I can't remember the exact numbers here. It's something like 9.8, 13.5, and 17.7 or some crap. I don't exactly remember. You could all do those right now with your calculator faster than I could finish this sentence if you had your calculators out. That's a hint. Somebody should be doing that because I'm still talking. Never mind, I'll do it myself. I feel like the little red hen. 9.8. 13.5. 17.4. Now, do I have feet measurements to put over here? Yeah. So I would go 9.8 and 13.5 and 9.8 and 17.4. And now I can do length and width to get feet, right? Yes. Now, what's wrong with stopping there? Jordy. Of course you need to multiply each wall by 2. This is not a TV show. We need 4 walls, yes? Okay, so I will take those answers and multiply them both by 2. And you get something like 603 feet or something. Which then what you will do? Then what will you do? 1 gallon will do 300. So what do? I divide by 300. And I get something like 2.02. Now, when you round that, you stop at 2. But in reality, if you went slightly over 2, even if it isn't past 2.5, do you round up in reality? Yes, because you got to buy that 3rd gallon of paint. Cool? Now, I would like to show you the easier way to do it, but one that requires actually thinking. 3, 4.1. Yes? 3, 5.3, yes? Use meters. So 3 times 4.1 times 2 is 24.6, yeah? 3 times 5.3 times 2 is 31.8, yeah? For a total of 4, carry the 1, 6, 56.4. Meters squared, yes? Now, if you're not thinking, oh, I need feet. Okay, so meters, I want feet. So 1 foot is 0.3048 meters. So 56.4 divided by 0.3048. Is that okay? No. And here is why. I've already got it drawn right here. That's 1 foot, yes? Which means it is how many meters? .3048. Right. Agreed? Is that a square? No. Okay. 1 foot. Now is this a square? Okay. So what is the square footage inside there? No, dude. Square footage. Dude, this side is 1 foot. This side is 1 foot. 1 foot squared. Everybody understand? But how far is this side in meters? 0.3048. So what is the meters in there? 0.3048 squared, which is something like 0.09 blah, blah, blah. Right? So when you are converting straight line measurements, you only need to convert once because there's only one dimension. How many dimensions are there in area? 2. So you have to convert by the length and the width. Does everybody understand? Yeah? So this would have to be squared because we're converting square feet to square meters. Everybody cool? What if it was cubic feet to cubic meters? What would be here? A 3, because 3 dimensions. Everybody understand? And of course, if you get out your calculator, do 56.4 divided by 0.3048 squared, you get 600 and something. Everybody cool? Cool. Now, do you see how this is way less work? But it required you to think, right? Because when you converting squares, got to convert both sides. Everybody cool? Cool? Yeah, good. Aces. Let's go to the next thing. I can't remember what page it is. It's something like page 230. It's exactly like page 230. Now we are going to talk about spheres. Spheres are slightly more difficult because they don't exist flat, right? A pyramid is just 4 triangles and a rectangle, right? A cylinder is just a circle and a rectangle, right? A cone is a circle and a section of a circle. Yeah? Easy peasy lemon squeezy. We can make them all flat. What happens if I flatten out a sphere? I get a circle. That's it. Because a sphere is kind of like a round pyramid, but in 2 directions, isn't it? It starts from a circle, and it repeats, it goes up to nothing, and then repeats, it goes down to nothing. Does it have to be up and down? No, I could have gone diagonally or any degrees, right? So spheres don't get to be drawn. So it was real easy to show how we built the formulas for prisms and pyramids, right? This one it isn't. These formulas were developed through trial and error. They were guessing until they got it. And back in the day, that meant guessing with a lot of pen and paper or pencil and paper work. Of course, they didn't have pencils and papers. They had reeds and papyruses and things like that. But it doesn't matter. It was a lot of work to do these. So I'm not going to waste your time with that. Today, and for spheres and spheres only, I'm just giving you the formula. Okay? But we are going to do a little bit of messing around with it, all right? First thing we're going to do is mess around with the surface area of spheres. Now, please notice there are 2 options here. If you have the diameter, you can go ahead and use the diameter. If you have the radius, you're going to go ahead and use the radius. Those are easy. It's self-explanatory, right? No problemo. Where do we use the word sphere all the time? When we talk about planets, we talk about things like that. But there's another shape that we use all the time that is related to the sphere, the hemisphere. And we don't talk about that one very much because you can see there's no formula for it. Now, you guys are intelligent. So a hemisphere is what relation to a sphere? It's half, right? So logically, if a sphere is 4 pi r squared, what must the surface area of a hemisphere be? You want to divide it by 2 and get 2 pi r squared. Agreed? And it's done, yeah? Let's do that. Let's cut this sphere in half. What did I just create? A hemisphere. Except if this sphere was solid, what's that? A new circle and a new surface, isn't it? So what do I really got to add here? I need another pi r squared for that new circle, yes? So what is the surface area of a solid hemisphere? 3 pi r squared. Everybody picking up what I'm putting down? Now, Harry, I need you to throw me your basketball. You may do a bounce. Whoa, jeez. That's okay. I'm so good, even though I wasn't paying attention, I caught it anyway. Now, let's pretend that our hemisphere is hollow. So, I'm not going to let all the air out of your basketball. But if I did let all the air out of your basketball, what shape would I get? I'd get a bowl, right? I could fill it with cereal and eat it, yeah? Everybody agree? So if it's a hollow hemisphere, and I were to put a needle in here, wherever the button is, right there, and let out all the air, this would be a U, wouldn't it? Yes. Now, if I blew all the air back in, would this surface still be here? So a hollow hemisphere has what surface area? The exact same as its related solid sphere. Everybody understand? Oh! Aight? Everybody cool? Okay, now, does that same kind of trickery, do you think, apply to volume? Connor says yeah. Mantosh says no. Fight! Who's right? It's a popularity contest. Connor, close your eyes. Cover your eyes. Mantosh, close your eyes. Cover your eyes. How many people agree with Connor? How many people agree with Mantosh? You close your eyes. I can't remember who said what. Mantosh, what'd you say? It doesn't matter. And Connor said yes. It does not matter. Right? Because if you were to cut the sphere in half, you're losing that volume, aren't you? Right? It's just gone. So we don't have to worry about adding or subtracting from it. All right? But we are going to do something with this. I don't like this written this way. Why? The fractions mess with your heads. So I like to write this as 4 pi r cubed all over 3. And if I'm putting that into my calculator, I want to use brackets. I don't need to use brackets if I'm just doing a sphere. But if I'm doing further calculations, I want those brackets there. And you'll see why on the very next question. Okay? So there's a sphere. So logically, a hemisphere is half of that, yes? So that would technically be divided by 2. But a fraction divided by 2 also makes you guys pee your pants a little. What is the real thing we do when we divide by a fraction? So if I want to divide by 2, which is really 2 over 1, I would multiply by the reciprocal, yes? What's the reciprocal of 2 over 1? 1/2. So let's do that. Don't be like the other class. It took a long time to answer this question. What's 4 pi r cubed times 1? Good kids. What's 3 times 2? 6. And of course, most of you stop there. Would Mrs. Bad Crumble allow that? Why not? Because you should simplify 4 and 6 to 2 pi r cubed over 3 for volume of a hemisphere. Yeah? Now, the next question we are going to do is idiotic. It's a math class question. It's got nothing to do with anything. Because you all need algebra practice. So, Amber's going to wrap up a basketball for her brother. Now, Amber's an idiot because she didn't deflate the basketball or put it in a box. She's trying to wrap the basketball. It's not going to be very hard for her brother to figure out what it is. But, so, let's talk. Is this a surface area or a volume question? Surface area, because the wrapping paper is going to go on the outside, yeah? So, surface area is 4 pi r squared. Yes, that's a horrible 2 squared. I see 2 variables in that question, right? What are they? Pi is not a variable. Pi is always 3.14159, blah, 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 blah. Whatever your grade 6 teacher asked you to memorize it to so you could win a gummy bear or something. Because every kid has done that. I've never understood why. I know pi to 100 digits. Great. I know my grade 2 phone number. Does that make me more intelligent than the next guy? No. Knowing how to use it is what's important. So anyway, what are the 2 variables here? R and surface area. One of them we know. What do we know? We don't know R. What is the radius? So let's rewind. One of them we know. What is it? Oh, you guys are so smart. What do I write here? 2,500. 2,500 is not a number. It's okay, buddy. I do it too. But we wouldn't say 40. 4 tens. Right? Okay? We're not French. 80. 80. 90. 90. Idiots. So dumb. Like, really, grow up. 4 20s and 10 more. Now, of course, some dialects of French have gone away from that. They have septante for 70, octante for 80, and nonante for 90. But the 4 old men that are in charge of the French language, they don't like that. They say, no! 80, 90, 70. Because 73 or 75 should be, or 77 should be 77. No, it's idiotic. It should be 77. That's not what you said. Now, all of you, when you go to French next semester, do not go to French when Miss Madame Gray or Madame MJ says, let's count, children, but en français, comptez, mes enfants. Don't go 59, 69, 70. Don't. 69, 70. And don't go 61, because that's not right. It's 71. But it should be 71. That's how smart I am. Because I'm smart. 4 pi r squared. Now, my job is to get to r with our good friend algebra. We're going to fight our way through with algebra. What do I got to fight my way through? You damn right I got to divide by 4. What else? I got to divide by pi. What else? I got to square root. So now r equals the square root of 2,500 over 4 pi. Now, is that a math class answer? Yes. Is it a real life answer? No, of course not. If you stop there at your level, I'm perfectly happy. But for argument's sake, as I said earlier, talking about calculator usage, because all of you grab your calculator for 9 times 23, you're already punching it in, some of you. I hear the clicks. I want everybody in this room to try and get me the IRL answer for that. And when you get it on your calculator, I want you to tell me what your calculator shows you. Go. Get out your calculator and see if you can get me the in real life answer. Go. What? I'm sorry? Okay, 3.9. Well, 3.97, you said? Okay, so we have one answer of 4. Keep going. 14.1. Keep going. Everybody should have done this. I should have 30 people saying that a number right now. I've heard 3. What do you got, Vicky? If you got 14.1, you don't have to say it. 4? We got another 4? We got a 4.4. $1,963. Anybody else? 44.3. Anybody else? That'll prove my point. How many radii can a basketball have? No. 1. There's 1 value for the radius of a basketball. Why is my class giving me 5? Because your calculator isn't thinking. Right? Some of you would actually write that as an answer on a test. And when I said, what? You would say, and I quote, my calculator said so. Now, if that were true, the basketball would be 4,000 centimeters across, which would be 40 meters. That's some basketball. Now let's stop, because some of you might say, well, obviously it's not 1,963, Mr. Myers, but some of you might have done that, which would mean your basketball was this far across, which also makes little sense. Some of you would say it was that one, which would mean your basketball was this big across. Again, not very impressive for the slam dunk contest if the basketball is that big. The right answer is, of course, 14. Now, the problem becomes this. When you guys punch stuff into your calculator, you forget that your calculator does not think. You know what you want your calculator to do. You want your calculator to take 2,500, divide it by 4 pi, and then give you the square root of that answer. But when you punch that into your calculator, a great many of you will punch in 2,500 divided by 4 pi. You might put times there, and then you will square root. Now, your calculator only knows proper math. What will your calculator do with 2,504 before it ever touches pi? No. It will do that division. Because BEDMAS says you do division first. Right? What you want your calculator to do is 2,500 divided by bracket 4 pi. because you need to divide by the whole thing. Everybody understand? So as you go forward in math class, more importantly in physics class, because in math class we often leave stuff like this, right? But in physics, you would need a real number there. Okay? So you use your head. Everybody cool? Now, just out of, because we're sitting here right now, this number next year is not allowed. Because this number is, of course, the square root of 2,500 over the square root of 4 pi. Which is, of course, what's the square root of 2,500? 50. What's the square root of, this is really square root of 4 and square root of pi, right? What's square root of 4? 2. So it's really 50 to square root pi. What's 50 divided by 2? So it's really 25 over the square root of pi, right? Now that is not allowed. You're not allowed to have square roots in the denominator. So next year, you would have to multiply this by root of pi, multiply this by root of pi to get 25 root pi over pi. And that will be your answer next year.
That is weird.
I know, right? But now, next year, when you see that, it's called rationalizing the denominator, you can all go, oh yeah, this isn't new to me. Ha ha, screw you, teacher man. But some of you will be in class with me, so don't do that. Because some of you may not choose IB year 1. Some of you may just choose pre-calculus 11, in which case you'll be with me. Well, you have a 75% chance of being with me. Mr. DeVries, who also does the IB year 1. But so does Mr. Keeley. By the way, I also would not recommend saying to Mr. DeVries, screw you, teacher man. That would be a bad idea. Okay? What do you think? One time, Jewel, I was reffing my daughter's rugby game, and a girl on her team ran across the line and didn't put the ball down. She ran across the line and was, and the other team came and knocked it out of her hand, so she didn't get the try. So I took away the try. And my daughter on the sideline yells, screw you, ref! I know, right? Okay. You people. Oh, we got lots of time. Let's talk about number 2. What do I got to do? First of all, number 2 is a real life type of question. Often people say, Mr. Myers, why do we do these stupid questions? It could take me 20 minutes to explain it to you. I'm going to explain it in 3. Every time you buy something, it comes in a box, yeah? Yeah. Do those boxes cost money to make, or do they appear out of nowhere? They appear out of nowhere. Wrong. They cost money to make. Who pays for them? No. You pay for them. Because if I got to put my product in a box for you, I don't want to pay for that box. You got to pay for that box. So if I don't package efficiently, what happens to the price of my product? It's got to go up. If I spend extra, prices can't go sideways. They can go up or down. Diagonal. All right, so let's talk about this question, yeah? What have I got? I got 3 golf balls and I got the box they're going in, yeah? I don't want to waste any space. So what do? Do I build the box first or the golf balls first? Right. So there's 3 golf balls. What do I know about those golf balls? They're equal. 3 centimeters each. Where does the box live? Around them. How big's the box? 3, 3, 9. I want to know the wasted space. What math will find this? No, I'm not math. I'm a guy. What math is going to find this? Addition? Subtraction. Addition's ugly cousin. So what do I got to do here? Is this volume or surface area question? Volume. So what math do I need to do? I got two volumes. What are they? Volume of the box minus the volume of the golf balls. What is the volume of... Now, stop here. Because the next step, you guys are going to do something weird. Most of you. How many golf balls are there? So wait a minute. That's a rectangle prism. A ret prism, because I forgot the C. Minus 3 spheres, yes? Now, some of you would go, oh, okay, no problem. That's LWH for a rectangular prism minus 3 spheres is 4 pi r cubed over 3. Now, some of you would actually do this and then multiply by 3. Do you need to? Why not? Because 3 and 3 do what? Cancel. Now, you've saved yourself a crap ton of work by showing work. Right? Now, once again, I remind you, do you have to show work? No. Yes. Jewel, I railroad you people into saying what I want you to say. Yes. There you go. What's the R here? The odds are most definitely in your favor. 1.5. Nice job. Woo! And you've still moved away from the drip, and you're still on fire. So, of course, that is 81 minus... I need a real-life answer, yeah? Try punching that into your calculator. Not square. Cube it. Now, let me ask you this. Can you punch that in the order you see it? Could you punch 4 times pi times 1.5 exponent button 3 equals? Would it work? It gave you an answer. Would it work? Isn't that bedmass? 4 times pi times 1.5 cubed? No, it's not. Because your calculator knows bedmass. Exponents first. Okay? So it will give you the right answer. Right? So you could punch that in. Blah, blah, blah. And then you would do your subtraction. Good? Good? All right, now listen and listen to me carefully. I'm going to start talking in about a couple of sentences into what I say. A few of you are going to start making noises. All right? Just trust me on this. I want you to do page 232, page 233. There it is. 2 sentences in. 234, 235, by Monday. So, now listen. Some of you are now thinking to yourself, well, that means he's going to give us all day tomorrow to work on it, so I don't need to worry about it at all. Wrong! Tomorrow we are going to be doing something different. It is going to be something of my own choosing. But those pages, 231 to 235, inclusive, are due Monday. And that, ladies and gentlemen, will be the end of our unit. You will do a review for homework on Monday. We will mark it Wednesday, start the last unit on Wednesday, and you will write your test. Start the last unit on Tuesday. And you will write your test next Wednesday. Wait, that's buyout day, isn't it? But you people are block A. That will screw you over. We'll discuss this next week. What? Oh, muffin. Put on a jacket. It's my favorite thing. I watch you teenagers come into the school when it's minus 15 in t-shirts and shorts. I'm so cold. Let me give you all the number one piece of advice I can give you. After high school, in the real world, it's okay to wear appropriate clothing. Okay? You do not need to walk around in your favorite Thrasher hoodie because it's minus 20 out because it's cool. You can wear a jacket. You can wear gloves. You can wear boots. You can wear toques. If you're in America, you can wear beanies or stocking caps because they're idiots and they don't use the word toque. Huh? You don't need toques and jackets in the school. It's heated. Soft, soft, softy, soft, 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 softy, soft, soft. That's all I hear. You know that lie that people tell you that you lose 75% of your heat through your head? That's only because your head is not covered. But never mind.
The grade 9 students, F through Z, and those that haven't picked up their forms, please come to the office and pick up forms.
I really think they could have done that more efficiently. I think they could have had a grade 9 homeroom. They could have distributed the packages to grade 9 teachers in Block B. I really think they could have done something better than having 250 kids go through the office during class time. But I'm not in charge. I'm a lowly math teacher. The lowest of the math teachers.